Hey everyone, welcome back to the channel. Just a quick one, hopefully. This is an Xbox One controller. I've changed the pot on this twice. This started drifting backwards, so it would be as if I was pressing the button slightly backwards here. So I changed the pot. It was okay, it was slightly better, but it was still doing this kind of like walking backwards thing. So I changed the pot again. So if you can see there how many times I've changed this pot. And I've had to bodge wires back because the pad's come off. I've been watching lots of videos on YouTube, and when I came across it, well, you can change the pot, but what actually Microsoft do when they make these things is they put the pot in, and because none of the pots are the same, they tune it. They hard tune somewhere on here and then test it so that the pot that they put in is centered. So if the old pot was way out and you put a perfect pot in, it's going to be out because it was tuned for a bad pot to start with. That's what I think's happened with this. What I thought I'd try and do today is somehow try and figure out a way to compensate for that stick drift by bodging on a resistor. Because all these things are doing is when you're moving this stick, all it's doing is it's changing the resistance on that wiper on that pot. So the plan here is, can I just leave that on there, and then on the up and down, can I bodge it enough to just skew it a little bit to move it back by effectively changing the resistance there. So that's going to be the little test. We've got this dodgy, shitty situation here. So what I'm going to try and do is get that to come to the middle by powering it up with my bench power supply, I think, and then trying different resistors and seeing if I can basically pull this back to the middle. Let's see what happens. So I guess the first thing we need to do is work out what these potty pots are. 5, 25, 5 and 10. 3.4k, 3.1k, 3k and 3k. So it looks like it's trying to regulate those pots down to a sort of a 3k each way thing. Okay, so let's screw around time. So what I'm actually doing here is going across these 2 points here, or these 2 points here, or these 2 points here, or these 2 points here. In this case I'm going here. Let's try 330k. Is it my imagination? It is moving this. It's moving a teeny tiny bit. So 330k is too much. Sorry, in terms of it's not moving it enough. So it's 59k coming up. You ready? 59k. You see that? That's 47k. We're going to call that good enough. Total cost of this fix, if it works, would be about 0.02 pence. I think that's our Huckleberry. 33k. Perfect. Okay, so I'm not obviously going to use one of those resistors. I'm going to use an SMD. I'll disconnect the power. Okay, it ain't pretty, but it doesn't really have to be. That is good enough. It's all back together now, and you can see that we're now perfect. I mean, left and right I haven't touched that, but up and down, perfect. In fact, it's better than the other stick now, I would say. So that will live to fight another day. Okay, so that's going to do it for this one. Thanks for watching. just a quick one. Hopefully, well, by the time I've edited it, will be anyway. Thanks for watching. Take care of yourselves, and I'll see you all soon.